Hello, everybody. It's 1:58 a.m. Central Time on the 6th of April, 2023. It's Thursday here in the United States. Hope you're doing well. Hearing the ding of the bell, another earthquake striking. We've had a pretty busy evening when it comes to seismic activity, hence the update. Late night, getting you up to speed on what struck, what we're going to expect over the next couple days. And to do that, let me get a display capture turned on so you can see my screen here. And we're going to start with the large earthquake of the day that struck down here, and it shows us a 5.1. Interestingly enough, it was a 6 when it first came in. It was downgraded to 5.1. Now, this is interesting because we have Easter Island right up here, this little speck of a dot, Rapa Nui, the volcano there. And we have a lot of activity going on below South America over to the east. So I'd like to get this open on a USGS map, show you what I'm talking about to the east. So the earthquake is out here on the fracture zone. And again, like I said, Rapa Nui or Easter Island is this triangular shaped island out here in the Pacific, East Pacific, but out here in the Pacific, and next to it, the fracture zone goes down to the east by southeast and to the north. You can see the red lines here on the map. That's the plate boundary for the Nazca Plate. Now, the Nazca Plate meets in with the Pacific Plate, and of course, it goes across over to the West Pacific, where we have a bunch of deep earthquake activity taking place. The deep earthquakes are raised high off the globe so you can see them easily, or the planet, depending on what you want to call this thing. We have the letter D's signifying areas where we watch for new deep earthquakes to take place. So, for instance, here up next to Kamchatka, here at Japan, 2 spots here at Indonesia, Philippines, 1 at Fiji, 1 over here at South America, and 1 all the way over here in the Mideast at Afghanistan. Those are the spots where we watch for new deep earthquakes to take place, and that's where they normally occur, forecast area-wise, and that's where we normally see it day by day. Now, over the past few days, there's been a few oddballs popping up in spots where we don't normally see much deep earthquake activity, like this 5 raised high off the globe over here to the east, and all the way down below Brazil's border with Peru. Now, in the past, when we see deep earthquakes like this, we tend to see shallower, larger earthquakes within 72 hours up to 7 days. Within 3 days to 7 days, we tend to see deep earthquake activity come up. 10 days in some cases, but usually it's about a week or less. Now, following this deep earthquake, this deep 5.1, we then had this shallow 6. So let me really show you what happened. First, a deep earthquake up here at Peru, then a shallower, larger earthquake here. They then downgraded this one over and over and over again to get it down to 5.1 from the original 6 where we started out. So what's really going on? Something's coming up from down below Peru, spreading up to the north and to the south, and to the west, of course, down below the Nazca Plate and the adjacent Cocos Plate, going into the Caribbean, up to the east-northeast. Now, a new earthquake has been reported here. Another 5.1 has been reported, this one at Nicaragua. Now, this is on top of the other earthquake that struck on the coast of El Salvador. So now we have 2 different earthquakes in our warned area. If you're not aware, a 6.3 earthquake struck on the coast of Panama. I had warned for up to a 6.3 to be striking here next to El Salvador. And I said we had to watch everywhere south of Nicaragua and all the way north into Mexico. Well, we're one country off, and there's the magnitude we were looking for. Let me show you where we warned versus what was hit. So I had warned right here, and instead it hit right here. The difference you can see is about 500 miles off. I'm trying to get it down to 200 miles as my ultimate earthquake forecasting goal. But we got it down to the day, or down to the specific time frame we warned for a few days' time. Got it down to the magnitude, got it down to the region. I'm pretty happy about that. So let's recap. A new deep earthquake down below Peru, spreading out in all directions from there. Look at the stepping stone path of quakes going to the north and to the south and to the west. So something's going on down below South America. Now, if you top that all off with the volcanic activity that's been reported, or, well, I don't know if it's been reported or not. Let's go over and check. Over here on the Volcanic Ash Advisory Center, we also see the volcanoes that have warnings or watches issued with them. Nevado del Ruiz volcano in Colombia, up on the north side of South America, up here. A new watch or warning for a big eruption was issued from the agency here. And that's something we can't ignore. It hasn't happened yet, but they don't normally elevate the warnings at this volcano in particular for big blast. So it's something to keep an eye on. Then this one, Ambrim volcano, also known as Aoba, that started to come back on the list. And that's not normally on the list. Same with Luatolo over in the West Pacific. But we're worried about what's going on in the East Pacific over down below South America. Here's Cotopaxi or Sotopaxi or Cotopaxi in Ecuador. And we have Fuego, that's a regular eruptor on the list in Guatemala. Sanjay in Ecuador. Nevado del Ruiz in Colombia. Cotopaxi again. And I'm probably butchering the way that's pronounced. You guys will correct me, I'm sure, but it's okay. Don't worry about it. What else is on the list? Well, we go down the list, and there's no new additions beyond the ones that I've named. Down in South America, the warnings and watches and alerts that you don't see on here, you have to keep up to date. They happen every few days. Down to the south, I don't remember the name of the volcano. I made a post on it. It hadn't erupted in 600 years. And I don't... Laguna something. That's all I know. It was on the list 2 days ago. Hasn't erupted in 600 years. Anomalous seismic activity down here in Chile. Right down here. I made a post on it on my social media, over on Twitter, and over on my community page. So Laguna del something. 600 years was the last time it erupted. So something's, and when I made the post 2 days ago, I said something's going on down below South America. Then this happens, and the deep earthquake happens. So it looks like we're building into some large seismic activity. The volcanoes are showing activity because there's a seismic disturbance coming up on this side of the Pacific, following all the activity over here in the West Pacific, which I don't need to recap for you, or if I do, you haven't been paying attention at all, because take a look at what's hit in the past few days. 7s, multiple mid-range 6s, all in a few days' time. A noteworthy increase from where we were, which I would tell you is somewhat next to zero or low. For instance, we went many months without any 7.0 level activity. Then get a flurry all in a few days' time? Pretty interesting. Where did it come from? How about all that power that got dumped out of the core of the Earth from the big northern lights and solar wind event that happened this past week? It takes about a week for it to go down and come back up with new deep earthquakes. And then, of course, when you have new deep earthquakes, it's shallower, larger earthquakes, guys. Listen, one more time if you're new here. Deep earthquakes down below, when you lift on something, are you shocked to see if you lift on something that's got cracks in it, that where you're lifting, it's going to transfer to those cracks and go up through them? Especially if they go all the way through something you're lifting on. And in this case, the lifting's coming from down below here, and it's spreading out on the red cracks that you see on the plate boundary map here, and coming up on the sides, like an equal distribution out around something that's being lifted on the underside. And that's what's happening now, but it's not just a person or something lifting on the underside of a piece of stone. It's Mother Nature with a very low frequency wave coming in on the underside of the plate. Same thing's happening over here, guys, over on the West Pacific. The distribution of earthquakes is somewhat equal across an unequal mass of the plate boundary, just like what's happening over here on the east side. See how we have 4 sets today over on the USGS map, somewhat equally distributed across South America. Same thing's happening over to the west. And just like over in the east, you got a 5.1 on one side. Well, darn it, look at that. A 5.1 to 5.2 on the other. Same size, same number, same everything. This is on the USGS map over the last 24 hours. Here it is 48 hours, and you should be able to see it even more. Same-sized earthquake, 6.3 on one side. Same-sized earthquake, 6.3 to 6.4. They brought it up on the other. Within a day of each other, 6.3, 6.3, and then the spread of 4s and the spread of 4s, and then the 5.1s and the 5.1s. Now finally, before we move any further, this 5.1, which is really a 6, got a screenshot of that in case you missed it. Let me take you over to my YouTube page, in case you haven't seen it. That's why I take screenshots, because otherwise we might get left out on the true information as it's presented before they change it. Before, when it's detected and it gets reported, then a human comes in and changes it down that far. I just wonder. So anyway, there's the 6, Easter Island to the north, and we're really on that red line plate boundary map out here where the quake is. Easter Island's on the north side of there, on the fracture zone. But where did that come from? It came from down below, over here, pushing up and spreading across. Think of this 6, and it is a 6, or it was a 6. This 6 coming across like a train going across a bridge. And as the train is going across the bridge, it's going to be making impact at the end of the bridge is a giant mountain it's going to be impacting into. And in the battle between the train and the mountain will win, and the train will be derailed around the outside edge or smash into and pile up into whatever it's going into, right? So the vibration of the train coming across the bridge lets us know something pretty big is coming across. We don't normally see this amount of vibration coming across. Normally it's in the 4 range or maybe 5. So when they downgraded it, I was shocked because we're going to see impact. This is a wave coming across now, and it's accentuated by our deep earthquake pushing up on the underside at the same time. So while there's a wave coming across, like a train going across a bridge, at the end of the bridge we also have somebody lifting up on the underside. So where it makes impact down here, that's where the volcano is that hasn't erupted in 600 years. Do you think it's chance? I don't. Deep earthquake down below. Traveling wave coming across. Anomalous seismic activity, as they called it. Anomalous. Yeah, well, we're moving on the north side, and we're going to be moving on the south side, and we're moving where the arrow points, and the arrow points to where the volcano is, where the wave is going to be making impact, and where it's coming up from down below. Meanwhile, West Pacific is moving. I don't need to tell you about that. Already made 2 videos in the past 2 days on it. The only new addition to the West Pacific is Australia started to move down, and this is somewhat more rare location. South Wales? When was the last time we had to look up an earthquake there? I don't recall. I don't think we have. So let's go take a look. Anything there? There might not be one single thing there, but for my Australian viewers, I'm sure you're going to be interested to go look it up. And I will be too. Might just find a new place to go live. Go live out here, go park my double wide out there and just disappear into the outback. Is that the outback? I don't know what it is. Okay, we've got the Kulgoa National Park. Okay, national parks, all right. That usually means there's something they're trying to preserve or keep out of the public reach. Is there anything else here nearby? I just have to look around. Again, they don't normally put big signs on them, but for oil and gas pumping operations, I do know that they had oil and gas pumping operations in Australia. I don't know who's going to get out there and do stuff like this, though. That's pretty interesting, wouldn't you say? Stuff like that. Looks pretty old to me. That looks pretty old. Okay, anyway, moving on. Let's, anything else here? I hate finding stuff that's mysterious because next thing you know, I want to go look into it. I want to look for any kind of pumping operations, any kind of drill points or large oil fields. Mining, mines, open pit mines, entrances to underground mines. Those would be the only things I'd be looking for in this instance. I don't see anything like that around the area. If you guys know of anything, please let me know. Right now it's going to be on the edge of the Australian cratons, plural. We have multiple cratons that make up the interior part of the plate, multiple parts of the interior plate. I want to say there's like 4 or 5 of them. Normally the flow comes in from the north, goes down all the way to the east-southeast, down next to Adelaide and Kangaroo Island, then down next to Perth. If we're really moving, we move around the outside edge down to the east-southeast and on the west side. In this case, you moved already down here at Adelaide. with a 4.8. You've seen 3s go around to the outside edge down next to Sydney, and 3s go down next to Perth. Now you get a 3 up to the east by northeast, more rare location after the 3 in the middle, just east of Ayers Rock. That's a lot of 3s, wouldn't you say? Wouldn't you really just say all of Australia moved on a 3.0 basis in the last few days? Going into last week at the most with the 4.8, with the 4.8 striking down here. The only one I missed was the earthquake that I'd warned for a 4-ish, upper 4, same-sized earthquake, 4.8, to strike here, down next to Perth. And instead, it hit down here on the plate boundary, 4.8 exactly. So it hit south. That was the spot that I missed. The rest moved as expected, 3s all the way around, and it can be traced back up to the west-northwest, where just major amount of movement going on up on the north side, of course. The north side of what? I mean, sorry guys, new people aren't going to know what I'm talking about. The north side of the Indo-Australian plate, where it's been moving with 6s and 7s and spreading across Australia down to the south. I would expect the east and the west side to move pretty big in the next few weeks or less. I only do 7 to 10 day forecasting. But for my people down here in New Zealand, guys, it looks like another 7's going to be coming in here, just north of you in the Kermadec Islands in the next few days. So get ready for that. I don't know if that's even going to matter, or it'll be out in the ocean. And the New Zealand agency, if it's out in the ocean, will list it as unnoticeable, because they base earthquakes on whether or not people notice them. I'm not joking. So if a 7 strikes out in the ocean just north of New Zealand, they'll put it on the unnoticeable. The market is unnoticeable, and you just have to check their feed to see if a 7 hit or not. Like, they don't put it up as some kind of big earthquake or something. It's weird. And that's how they classify their earthquakes, as noticeable and unnoticeable. For notifying the public, I mean, generally. Okay, anyway, let's move on. How about a new same-sized earthquake, 6.2 to 6.3, upgraded to 6.4, striking on the plate boundary in Philippines. Check Philippines off the list if you're keeping track of areas that we named last week. Japan did not get hit last week where we were expecting at all. It struck, and it was a magnitude less. We had warned for up to a 7. This is last week's forecast. We had warned for up to a 7 to strike here, and instead we got a 5. Then I doubled down on the warning, issued the warning for the 7 again, and the 6.3 hit right here. So what really happened, it took a week longer than expected to break on the coast of Japan. Now it looks like it's going to break again on the plate boundary, but I'm not going to put a magnitude on it yet. I'll get into that in a few minutes as to why. Because it looks like we're looking at a huge earthquake coming, and I don't think it's going to be, knock on wood, I don't think it's going to be in Japan. I'll explain by the end of this update. But I think we're looking at a very large earthquake coming, bigger, that's dwarfing the size of the 7 that just hit. So, for instance, if an 8 hits, that's like 10 7s added on to that 7. That's like 10 more 7s to make it an 8. And if anything bigger than an 8 comes in, then we're going up by a factor of another 10. So, anyway, okay. So there's a line of earthquakes going around the outside edge of the Indo-Australian plate. Past 2 to 3 days shows it goes around up through China, back down through the Indian Ocean. Around up through China, back down through the Indian Ocean. Look familiar? It's the path the earthquakes are taking. USGS map doesn't show this because we're looking at 1 day's worth of quakes. But in the last 3 days, the whole edge outside, including south of Australia, has moved on a 4 to 5.0 basis. That's a huge area to move in a few days' time on that level. If it was just 1s or 0s, we wouldn't even get notified. But we're talking about 4s, 5s, 6s, and 7s going around the outside edge. So far, the 6s and 7s are on the north side by Australia. I would think we're going to go over next to New Zealand, like I said, in the Kermadecs, and I think we're going to go over to the west. Over to the west, we already had a 6, so stands to reason we're going to go to the west some more. And if we go to the west some more, where do we go? We go to India, where India meets into Iran. So, gotta issue a warning for Iran. The Iran-Pakistan border region is due for a potential large quake in the next several days, going up to the near 7.0 level, just like all the rest around the plate. But when we're talking about a huge earthquake coming, I'm looking more back here This goes back next to Papua New Guinea, Solomon Islands, Vanuatu, as a potential large earthquake that could produce a tsunami in the next several days. Just because the outside edge of the whole Indo-Australian plate is moving, and it's moving down below, spreading out to the other plates, you can see they're moving. So something's coming up from down below here, and that means there's going to be a big break, most likely here. Down below South America, I think we're going up to 7.0 level activity as well, 6.9 to 7, and we would look in the middle of this, down next to where our volcano is in South Chile. When I say the middle of it, I mean the middle of the whole mess going down to the South Sandwich Islands. That there's no earthquakes down at the South Sandwich Islands down here on the USGS map. Hold on, let me show you. But we go back 2 days and there is. So the middle of the mess from up here to down here puts us right in here, where impact is due, and it should be pretty big. But the biggest of the bunch, I think, should be coming in over here in the next 7 to 10 days. And if anything changes, I will do a new update, but I think we're going to be going up above 7.9. That puts us into the 8.0 range in the West Pacific. Like I said, 7's over to the west, so it's not like they're going to escape over to the west. It's going to be big. It could be upper 6. But if you know anybody in eastern Iran, Pakistan, southwest Afghanistan, let me show you the plate boundary there so you can get an idea of which countries I'm talking about. Over here, already up to the north at Tajikistan, we had a 7 2 weeks ago, 3 weeks ago. We had the 7s over to the west at Turkey. So, around Iran, that would be the final spot to watch for the final break to take place. I struck out on my last warning for a 7, just so everybody knows I struck out in Greece. It did not hit in Greece at all. So, back to it. Let's go back and look one more time. A spread of earthquakes going around the outside edge of the Indo-Australian plate, pointing over towards Iran as a spot to watch for a new large quake. A very large earthquake coming in here into the West Pacific. I hope I got it right, that it's going to be out in the middle of nowhere. But if it generates a tsunami, people in Papua New Guinea, Vanuatu, Solomon Islands, going down to the south coast, down south to the coast of Australia, would need to get ready now for the potential of a large quake. South America, same thing. They're used to large earthquakes, but when we get into the 7 range, you might want to let the people know down in Chile that the volcano with the 600-year thing, I mean, it could go or not. I don't issue forecasts for volcanoes, but you start seeing a volcano that hasn't gone in 600 years. You're moving on all sides. You've got a 6 they just downgraded to a 5 suspiciously, and it's coming in with a wave. Think of this like a wave that's coming in. You wouldn't ignore it, would you? Going over to Europe, let's talk about this. So, Turkey started to move again, and it moved all the way across Turkey from north-central Turkey to central-central Turkey and south-central Turkey. Since doing my last update, here's what's hit. At least according to the Europeans. USGS is ignoring a lot of the quakes here, so I don't know if this is an accurate picture of the 4.0 plus, but I'll just say it. We've dropped off. We dropped off here as we picked up over to the west, Tunisia, going over to Algeria, and we picked up to the north, up into Poland, with a new earthquake at the Polish border. So, Poland, Tunisia, why are they moving? Let's go back and take a look. Tunisia over here, Poland up here. Both are moving. Why? The energy is going out of Europe now. And as it does, we drop down where it was broken, where it was trapped, and it went up to the North Pole, as expected. We talked about Jan Mayen, the small island right here, Svalbard and the North Pole. I told you when we saw flow go out through Poland, we should see it pick up here. Now both have happened. Flow went around through Poland and struck with the final blow up at the North Mid-Atlantic Ridge. Let me show you what really happened. USGS map has nothing on here, but we have a backwards S-shaped bend in the plate there. Let me show it. You can even see it on the topography here of Europe, this mountain range. Now the mountain range, the Carpathian Mountains, isn't that what it's called? Anyway, on the edges of each of these, we've got volcanic features at each bend in the craton edge. And the earthquakes go around the outside edge and flow out to, ultimately, around Europe, out to the mid-Atlantic ridge. It's a wave trying to go around something. A wave of something trying to go around something physical. And it's an electrical wave, by the way. Before we get into the lower 48 United States, let's go quickly talk about Central America, which started to move pretty significant in the past couple days. Multiple fives. Take a look at it. First of all, 5 struck right on the coast of El Salvador. Then a 5 struck at Nicaragua today. Yesterday, the 6.3 struck down to the south. That's pretty amount of big movement going on there. And then mid-range 5 striking in South Mexico. Now, that's not huge for Mexico, but combined, look at it. This is the last 2 days. This is an increase from where we were. We were at next to nothing here. We had 4s. We took a step up to 6.3 plus a bunch of 5s. And it spread out somewhat equally across. One more time. You're going to be so tired of seeing this after watching 100 of my updates. The plate boundary here. It's going to be beaten to your head. You're going to remember it forever. Along the edge of the plate boundary, an equal distribution, somewhat equal distribution going from South Mexico down to Panama. Well, gee, look. What is that? That's the edge of the plate boundary that meets up to the Caribbean, coming out of the Nazca Plate and the Cocos Plate. Nazca to the south, Cocos here. And we're being fed energy from over here. It's spreading out across this way, dropping off the earthquakes along the way. That's why we're getting 6.3s everywhere right now. It's dropping off 6.3 to 6.5 level energy around the planet. Go back and watch my forecast from this past week. We called for this when the 7 hit. I said we should see a series of mid-range 6s pop off across the whole plate on all sides, equally distributed out. I named the areas, including Sumatra, Indonesia, Kamchatka, Russia, Philippines, South America, Chile, and Central America at El Salvador. All of the spots have been hit, save one. So that's 5 out of 6 being hit with the expected 6.0 level activity within 5 to 6 days of issuing the forecast. I'm not bragging, I just have to keep track because, who else is going to except for a troll? We know they can't be trusted. All right, now getting into the United States. Alaska, we're watching. We're down to this last day. Tomorrow is the last day of the warning for Anchorage, Alaska, to be on watch for a 6.3. So, one more spot to go that hasn't been hit at all with any significant activity, and that's Alaska. The rest have moved. So, we're down to the last day again, and 6.3s have struck pretty much everywhere. I've already covered them. 6.3 Central America, 6.4 West Pacific, 6.5 up at Kamchatka, and so forth. So, the only spot to go is right here. And wouldn't you say this is the center of the mess of quakes across from the Aleutians over to Canada? If you were to find the center of it, just to generally say the triangulated center of it, wouldn't you just say it's somewhere in here? And look what's there, Anchorage. And our warned area is Anchorage, south of the plate boundary. Last day of the warning expires tomorrow night at midnight. I hope I'm wrong. Hope it doesn't hit. Or if it does, that it's out in the ocean. Okay. Hawaii's forecast was fulfilled. USGS downgraded at 3.9. Yep, y'all. They got a 3.9er up in there. Oh, man, I can't believe it. Seriously, they downgraded it. But it was a 4. It came in at a 4.1. We had warned Pahala down along the coast to go up into the 4-ish range. It did. They downgraded it. Whatever. It's a professional feud at this point. It's like chess. Let's go into the United States lower 48. We still have the earthquake from a day and a half ago there on the screen. You can see it there, the 4 that struck on the creeping section of the San Andreas. That's next to Monterey Bay in California. We can get that out of there from yesterday. Hold on. There we go. Here's everything that's hit since. A spread of earthquakes has gone across the North American craton with a noteworthy increase going back into Oklahoma, of all places. We have a warning going in Oklahoma, but it's for 1 magnitude larger exactly. I warned them for 4.0, and a 3.0 to 3.1 came rolling in. Now, I'd like to pull the coordinates, go look it up, see what's there. Since we issued a warning and it's been a while since you went up to near 4.0 level, let's go see what the magnitudes actually reported are on the station details. Now, we're going to throw out the high end. We're going to throw out the low end. And that's going to give us a better idea of what actually hit. Magnitudes listed over here on the right-hand side. And I'm going to throw out the low-end 3s. We're also going to throw out anything that's probably 4.0 plus. Let's just see what's on the list. Wow. Okay, we're going to throw out the 2s, and we're going to throw out the 3.8. And what that is going to leave us with is more like a upper 3 to low 4, or maybe at the highest low 4. But I'll just say it. That's the quake we're looking for. We were looking for an increase to come back into Oklahoma after a time where we were only having 0s, 1s, and 2s. To take a 10-fold increase in power. To go from 2s to 3s is 10 times more power. So let's go in and see what broke. New viewers, take a look at the screen, please. Class, please look here. We have a typical farm field out here in Oklahoma. Across the street is a new kind of farming. This is fracking, wastewater disposal. They'll build these berms around here in case this thing breaks and releases the toxic chemicals that they have in the tanks. They'll take that and mix it with fresh water, the toxic chemicals, inject it down into the ground in a process called wastewater disposal, but really it's to get rid of the nasty water, and the nasty water breaks down the shale in a process called fracking, wastewater disposal fracking, that breaks apart the shale and releases oil and gas. Then they'll install some pumps on another nearby area and create pressure, drill at an angle, and get that gas and oil out of there. Drill by miles. And they have these fracking operations all around here, and they are just all over the place. You zoom in on these square pads that are in the ground there. They're easy to identify from air. The state has made it that way from state regulation. There's about 500,000 different drill points across the state, and you really have to know what to look for, but once you start to zoom in and you start to find all the pads all around the area, you know they're drilled. Drilling leads to earthquake activity at the drill points. Just like a perforation in a cardboard box enables you to bend the cardboard box more easily along the perforated edges. When you drill something, it makes it easier for a crack or a wave or a power or a force to go through it if you're applying that power or force to the greater mass. In other words, if you got a big piece of stone and you drill into it a bunch, guess what? If you apply pressure to it, it's going to follow those cracks or those drill points that you've placed into that stone. Just like drilling teeth, too. I mean, there are cavities in teeth. You apply pressure to your teeth that have a cavity in them, guess what happens? Breaking occurs between the two easiest points for the force to travel across. Okay, remind me not to hire the USGS to help me move any furniture, especially stone countertops. They said none of this could happen. Now let's go up here because look who got hit. New York. New York. Guys, New York. Okay, hold on. I got to measure and see how far off I am. I issued a warning for New York down by Delaware. New York, between New York and Delaware. So here's New York City, and here's Delaware, and those are about 100 miles apart. I'm going to say this is like 250. Just a guess. 30 miles is an inch. Maybe 300 miles at the most. Anyway, we're on the edge of the craton with a rare earthquake in New York. Should we go look it up, see what's there? Since it is a rare East Coast quake, next to where I issued the warning. Now we're a magnitude under. A day late and a dollar short. We're a magnitude under and we're 200-something miles off. There's a water tower here, but don't mistake that for anything unless there's aquifers down below. Let's just think that water tower is with something else. Turn on our borders, labels, and places so we can get an idea of the names of the towns. Port Byron, Auburn. Now those are some interesting looking lakes, wouldn't you say? Okay. Oh wow, really interesting. Hold on. Surprised I never noticed this. Seneca Lake. Oh wow, they're named after the tribes. Hold on. This might be something we have to look into further, actually. I'm not joking, guys. So I'm recording this, so I'm not going to really make a big deal about this now. But when I find stuff like this, I start to look and see if maybe there's some other reason for it to exist. Did it exist before man-made lakes or otherwise? And we tend to find a shape embedded into so many of these features that it's starting to get suspicious, to say the least. And I could show you many other examples, but like I said, I don't want to get too far sidetracked. That being said, let's get back to the seismic information and go look on the West Coast. So really quick, let's turn down the earthquake rings so we can get a better idea of the areas which are moving. And I can even turn off all the numbers because that seems to get people so confused. Whoops, wrong button. There we go. So really, we can just play a game of connect the dots. We can go from the cluster up in Washington, down across Idaho, then down through Utah, down through Texas, back up to Oklahoma, over across the New Madrid, and up the East Coast. That is the edge of the craton, and this is 48 to maybe at the most 72 hours worth of earthquakes. In 2 to 3 days' time, you can see the spread going around the edge of the craton. It's a huge discovery to find out that there's a flow of something going around the edge of the plate that's causing the earthquakes. Something's flowing around the plate, causing the dang quakes. And it's the same sized energy going from the West Coast to the East Coast, dropping off 3s in this case all the way across. We started with 4s on the West Coast. We have 3s going across the plate. We're due for a 4 up in the Northeast. It maintains momentum across the plate. It doesn't lose energy. So that kind of defies the equations of, I was going to say the law of elasticity, but we'll just call them the equations of elasticity because they might be incorrect, at least implied to very low frequency going through plates. There's not much loss of momentum. The plate's not absorbing anything or very little. We get the same sized earthquakes going across the plate. It's not that one earthquake's causing the other. It's that there's some kind of force going across the plate that's dropping off the same sized energy across pretty much the whole mass within a magnitude of each other. Okay? Crazy, right? Now let's look at the small earthquakes. See what's going on here. Up in the Northwest, anything new? Ooh, we're back at Mount Rainier, right below the crater. You guys want to see the crater of Mount Rainier? I mean, if you're from the Northwest, you see this like daily when you're going out of your house or something off in the distance. But down below the crater, there is a little bit of seismic activity that starts to develop when there's a disturbance, a greater disturbance in the area. And the area I'm talking about, the Northwest in this case, we're talking about all of Washington, all of Vancouver, all of North Oregon. So we're on the side or flank of the volcano. There's the peak or tip, and you can see it. There's the well-known crater, and it's got a fracture going across the center of the glacier in the crater, but don't worry, it's not going to erupt now, at least not that I know of. We would see thousands of earthquakes there. So it's just a few, it's a handful. The wave is passing through here, exciting the volcano slightly as it's heading over to Yellowstone to go down through Colorado. We've got a warning going in southern Colorado now. In case you didn't know, southern Colorado has been warned for 4.0 level activity as well. Okay, where are the rest? So we're around Mount Rainier. That's a no-brainer, the volcano. The rest of the small earthquakes are going across from all the way up here next to the Puget Sound or the Strait of Juan de Fuca. That's not really the Puget Sound. That is the Strait of Juan de Fuca. And then we go down onto the Seattle Fault. Now, I don't know this one to the south. Hold on. Oh, well, okay. This one to the south is an explosion. That would explain why I don't know what's there. Let's go see what's going on at this location where there's an explosion. Had to be pretty big considering there's no other explosions reported in the whole country. Or maybe in Oregon there are. What's going on? What are we blowing up out here? A golf course. Man. Got a golf course out there. They're blowing it up on the golf course. And man, he was the bomb today. It was... Okay. All right. Okay, so what else is here? Anything else worth mentioning? When we have something like that, I want to look around and just go see. Like, for instance, you can't ignore the huge set of high voltage power lines that goes back here to a branch of even more. Look how many there are. Hold on. 1 set, 2 sets, 3 sets, 4, 5, 6 sets of high voltage power lines. Where do those go back to? Hold on. What do we got going on here? What's this place? Some kind of gigantic substation. Wow. Well, I wonder, are they doing some kind of large power generation up here that we need to be made aware of? There's the substation. Where's the power coming from? Huge trunk of power lines. We got a nuclear reactor up here that I need to be made aware of that I just don't know. I mean, with a lake this big, I wouldn't be... Are those lakes that connect out to the ocean? That's a Puget Sound. I don't think they'd be unwise enough to build a nuclear reactor up here in the Northwest. Do you? I don't know. Another huge substation. All right. I don't see any power generation there nearby, but the transmission lines cannot be ignored. An explosion at the golf course next to the transmission lines. Gee, I wonder what the explosion's related to. Let's go out here and take a look at the 0.4. Now I'm suspicious. Got to look them all up. This is where you call me anal retentive Dutch sense. Pardon my language, but start going to look up all these locations. All right, we're at a 4.1 kilometer depth. I wonder what's there. Start getting suspicious. Uh-oh. Dude. See, this is why I get suspicious, okay? Right here, this spot right here, the hydroelectric dam. The hydroelectric dam, we're right next to it. We keep getting hit with earthquakes coming off this set of power lines. The power lines comes up. It's kind of hard to see. Goes to the substation. We have to follow the lines out. You see that there? They go to the west. And they go up to the north. But they go up this hill. See that? Gotta make a bend down to the south. Now, if you follow them, you also see they make a fork and a branch and they go up to the north. They follow through up here. And our earthquakes, where they branch off, and it's kind of hard to make it out, but it goes across the river and goes up this river valley, up this way, where they have the clear cut. Anyway, earthquake striking along there. Another electrical. But that one's an earthquake. This one's an explosion. Explosion. An earthquake. Both sides of the area that's moving in the middle where the volcanoes are. Oh, man. Dude. This is one of my other large discoveries. That earthquakes are striking next to man-made power facilities, such as power stations, not just hydroelectric dams, but transmission lines, power stations, nuclear power, solar power, wind power. If they're generating a lot of power, it's very low frequency. 60 hertz is what they're putting out through the line, 60, 120, and 180. 180 is the conch shell sound. The sound that you would hear if you blow through a conch shell. But it's not audible to the human ear, but if you could hear it, it would sound like that. Like a whoo sound. I hate to do that impersonation, but that is what it would sound like if you could hear it. On the conch shell, 180 hertz. You go lower than that, you go down 2 octaves, or in music terms, you call it octaves. Okay, anyway. All right. Down to the south we go. What's with the 1.5 down at the border? Where there's one, there's more. Let's go look. Inquiring minds want to know. Carson, Washington, down along the border with Oregon. This is why you have to look up the small earthquakes, class. You might start to find stuff, make big discoveries on things that people missed, like the earthquakes, the very low frequency, power lines, going through the same area and the earthquakes following where the power lines are, most likely like a circuit would direct power through a circuit board. Here we are. We're on the south side of Mount St. Helens. I wonder what the earthquake's related to there. Let's go down to the south. What's this? Oh, another trunk of high voltage power lines. I wonder where they go back to. Oh, wow. Dude, look at the size of this hydroelectric dam. Wow. That's mega massive. And there's our power lines coming off of it. And we're going up on the trunk of power lines. And we're right next to them, just by a few miles. This very low frequency can spread out many miles. Very low frequency. Peaks between waves can be hundreds of miles, but that's in Mother Nature's very low frequency. Wow. branching out right next to it, guys. Look, they built the big power station in between the two volcanoes. Flowing water, two volcanoes, big power station. Somebody else knows something aside from me. That's a lot of earthquakes to be happening next to power, guys. That's a lot. Let's go over along the border over in Oregon. Deer Island, Oregon. I think I'm proving my case that the earthquakes are striking next to power facilities and power lines. You can't tell me the power lines are everywhere. You just can't. We're not talking about power lines to your house. We're talking about the huge transmission lines and stations that generate the power to begin with. Okay, Deer Island. So help me God, if there's another power station right here, I'm going to freak. I hope there's not. What's this? Oh, okay. It's a mall or something. The Columbia River. Oh, wait. Of course. Look, there is. There really is. I'm not joking. The big set. Huge set of transmission lines right next to the quake, going along the ridge. It is. And, hold on. That's a bridge. We look for power stations. We're looking for power stations along here. If there is, we've got ourselves a problem. We got a lot of mining. Wait. Oh. Dino something. Oh, great. Okay. And a huge, huge steel factory, power generation out there. You know what? Okay, I'm getting sidetracked here. Looking up all these small earthquakes are going to keep me just ranting. If we go down here to the south, we're at Mount Hood, a place called Government Camp. We're on the side of a volcano. We don't have any other earthquakes to report to you across the whole state of Oregon, so we can just pretty much skip all of Oregon. Once we get into California, we have a line of earthquakes coming in and going down to here, where there's a massive stack at a place called the Geysers of California. Now here where the massive stack is, I'm going to zoom in on another spot, and I just want the class who's new here, the people who are new freshmen in class, to take a look at the screen. We're going on the side of a volcano called Clear Lake Volcano, but there's something here. See that? See these power lines coming off of here? Those power lines are going back to, you see it, steam turbines. And the pipelines are taking steam to the turbines to generate electricity. That's where the big stack of earthquakes is, north of the Bay Area. Once we go down through the Bay Area, I haven't looked up these small earthquakes, and I don't know if I should. Could get me in somewhat of a bit of trouble. So I'm probably going to just pull one and see what's there at Danville, California. Danville. Wonderful. Let's go see. Anything in Danville that I should be made aware of before I zoom in on this? Ah, yes. Okay, we've got an intersection. We've got a lot of residential. This is to be expected in the Bay Area. We've got a park, and I'm just making sure there's nothing weird here. Okay, the good news is there's nothing weird directly at the location. The bad news is we're at the foot of Mount Diablo. Now, there's a story attached to this. An earthquake swarm struck at Mount Diablo. And when it hit, it first started with small earthquakes that got ignored. Went up into the hundreds of earthquakes that kind of got some people's attention. Then it went up and hit in the near 5.0 level and caused a big shakeup here in the Bay Area. Followed by more swarming going on and the mainstream media paying attention to it. Now, I made a video on it and showed the swarm, showed the big earthquake, and then looked into the history of it and found out that it actually is an old volcano. Now, in my video that I put out, this is like, gosh, this has to be like 2013, so 10 years ago. In my video, when I put it out, the mainstream media picked up my video and denied that it was a volcano. Professionals showed up and denying it. I then pulled the studies and books that I had found, naming that there was tuftage found at the top of Mount Diablo, indicating that it was, at some point, an ancient volcanic feature that rose up out of the ocean and then hardened off or whatever, and the tuftage is up on the top of the mountain. Anyway, they disputed that it was a volcano. They tried to lay, because, again, people start to freak when you tell them a volcano's getting hit. They would think it's going to erupt. It's a previous fracture point in the crust from Mother Nature, from this old volcano, right along the fault. There's so many more. There's one up here to the north that I just showed you. This one, Clear Lake Volcano. Turn my places back on. There's our Smithsonian place mark for Clear Lake Volcano in Mount Canocti. So it's no shock that volcanoes form along the sides of huge faults and plate boundaries. There's another one down here in Southern California, right alongside. That's Salton Sea, Salton Buttes Volcano. Anyway, line of earthquakes going down to the stack that's at Geysers. And then, of course, we go through the Bay Area, and I don't want to get in too much trouble looking up spots. Down to the creeping section we go, and I don't need to show you the creeping section of the San Andreas. It's in every movie. You've seen it. It's a giant crack in the ground, and there's buildings that are even built on it that are moving one way or the other, but I can just show you the diagonal line here on the screen. And that's the San Andreas Fault going up to the creeping section right here. And it really is creeping side by side, one side moving one way, one side moving the other. And that's where we are now. Now we go down here and we putter out with earthquake activity. It literally looks like it's dying out right here. A place called Parkfield Cholame. Cholame? Cholame. Cholame. I will never be able to say it right. It's probably said all the ways that I just said it, plus some. And we will search and see what's next to it. Why are we going down here and just puttering out? Why aren't we carrying on down the San Andreas? Well, over the past few days, energy has come down and jumped over to here. And over here is marked oil wells. And there's even more right here. Coming down through the fields, going down to here. Just thousands and thousands of drill points, oil and gas. Going through the fields, back up to here, back up to here. And even further, back up to here. I've showed it so many times. Again, this is just for the new viewers who've never seen what a large oil pumping operation looks like from up above. So our earthquakes, our wave comes down to here and then jumps over into the valley. And that just happened. Jumped over into the valley, went over, and has now reached down to Southern California. Southern California is due for a new 4-point something, most likely 4.5. Now, they already had a 4.5 here 2 days ago on the creeping section. Now we're due for a new 4.5. I would say maybe even bigger. Could go up to 5. And I'm going to warn the center of the LA Basin. This is a new warning that I'm issuing now for the center of the LA Basin. Just keep watch for it, mid-range 4 to 5, coming in the next few days. I'm shifting the warning area from here at the border to here in the LA Basin. The reason I'm warning the LA Basin, it's kind of sandwiched in between all this activity coming in from the north and this big cluster down to the south. It's just a rough halfway point between all of them. And anytime a mid-range 4 comes in, I had a guy from LA write me actually 2 days ago and say, don't even tell me if it's going to be under a 5. I don't know. If it's the middle of the night and things start shaking, it's going to wake you up. You probably want to know it's coming. If it's any bigger, you definitely want to know. If I miss, the good news is my track record over the past few weeks and maybe even a few months in California has been pretty bad. Like the earthquakes are striking out in the ocean instead of on land, or a magnitude under and what I'm looking for. So that's been happening. That's the good news, right? The bad news is that the spread of activity that's taking place is big, and we're about to go back up. I think we're going to go up to 8 this coming week. With all this deep activity, I haven't even checked the solar today. I know we had an X-class flare again. I know there's been strong solar wind, strong northern lights, air glow in the northern atmosphere coming down from the North Pole. That electricity goes down to the ground, which is the core of the Earth, and then it comes back up. It vibrates back up, the core of the Earth vibrating like a bass drum, like an electroplasma in one of those plasma balls you might play with that you touch your hands to the outside of the glass and the plasma tendrils come out to the outside edge. It's actually amazing what I think is going on down inside of the core of the Earth. And it's something worth looking into. I think that if I were to properly explain it, people would understand it better. But to see the core of the Earth, you can't see it. So you have to imagine a plasma ball in your head. You know what? No, you don't. I'm going to search something. And I'm going to give a big shout out to somebody. Mr. Fix-It Rick. And Mr. Fix-It Rick is a guy who did an experiment where he took a plasma ball and started spinning it physically on top of it already spinning electrically. A plasma ball, you know what I'm talking about here? I'm going to hit play, and this is a big credit to Mr. Fix-It Rick, who deserves all the views. He's given me permission to play this video before. But I want you to see what happens when you spin a plasma ball. Now, first, you have to know what we're talking about with a plasma ball and see what he's doing. He's got the plasma ball, battery-powered, plugged in on this thing, and it spins. And he has a remote control. This is some kind of motor. And he brings this thing up to several thousand RPM. And so here's what a plasma ball normally looks like, and you would touch your hand out to it, and those tendrils would be drawn to your hand on the outside of the glass. And they're randomly moving around inside of there on their own in the gas, finding their path of least resistance out to the edge to seek to ground. Now, this is oscillating. Now, that's a complex term. It means back and forth. Electricity oscillates back and forth. So, back and forth, electricity. But it moves back and forth through space-time as it's moving forward through space-time. And when something's moving back and forth, oscillating, and it's moving forward through space-time, it actually goes into what's a sine wave. And three-dimensionally, it's a corkscrew. So you got to understand that this electricity in here is already rotating or oscillating back and forth. And it's rotating three-dimensionally because it's moving through space-time. Hence, it's rotating around like this. Now, look what happens when he brings it up to speed, up to several thousand RPM. The tendrils cease to be disorganized. And I'm calling this, what he's doing, hyper-oscillation. Taking something that's already rotating electrically and then physically rotating it. I propose to you this is happening in the core of the Earth. Let me show you. That this would be Earth standing still, just reaching out in all directions. But then with very fast rotations, here, let me just show you. Here, let's turn this back. As he brings it up to speed, they immediately separate into a full North Pole on their own and then break into a magnetic field you can see with the human eye. And this is what the Earth's magnetic field would look like if you could see it. But you can't see the Earth's magnetic field. This is plasma that you can see in a gas. But it's doing the same thing. Now look, it forms tropics and an equator and a hard fixed North Pole. And he proves it's a hard fixed North Pole by putting a piece of foil on the outside edge of the glass. And the hard fixed North Pole stays fixed north but tries to bend towards the foil as he brings it up to speed, and we'll just watch him do that here in a second with the foil in a second. So here it is going up to thousands of RPM, revolutions per minute physically. The post is rotating. The plasma itself is rotating. But then it's oscillating already too, and so I call this hyper-oscillation. You're taking something that's already oscillating and doing it more. Hyper. And then it breaks into its own magnetic field. Now, I would think that if you did this with a more powerful source, it would generate its own gravity. I don't know, but I think it would generate its own gravity. And I would think if it's big enough that that process right there, down in the core of the Earth, lightning or greater power, would generate an electromagnetic field going far out beyond the glass, beyond the crust of the Earth. And that's exactly what's happening with the Earth's magnetic field. It goes far out into space. It goes far through the crust all the way out into space. And I think if you took a meter and put it next to this, you would get a huge electromagnetic field reading coming out from that, going through the glass. More than it would already be when it's just on its own right. Now look what happens when he turns it off. Watch. And again, if for a hard fixed North Pole, and as he slows it down, they start to go and reach back out to random. And then you can't tell me that's inertia or momentum. It is, but it's with physical electricity. It's electricity taking inertia momentum. It's like the fourth state of plasma, or the fourth state of matter. I think this is happening in the core of the Earth and being powered by the sun. And it's hot enough to melt anything, including every element known to man. Now, when he puts the foil on the outside, I want you to see that as well, because it's proof that the hard fixed North Pole... Let me go fast forward. Oh, he turns it sideways. Yeah, that's the other thing. You can't tell me it's gravity or something like that. He turns it sideways. Now, where's the foil? There's the foil. So, there you go. Wild, right? Now imagine that as the atmosphere on the Earth. A aluminum particle coating. That it would attract the electricity up and out of the core. And we know lightning comes out of the ground and goes up into the sky normally. There's cloud-to-cloud lightning, and there is cloud-to-ground lightning, but a majority of the lightning comes out of the ground and goes up into the sky because of the differential in power, of the scuffing of the feet of the atmosphere, of the particles of moisture and so forth in the atmosphere, creating a differential in power between the ground and the sky, and you get a discharge of electricity, but that electricity is coming from somewhere. It's coming from the core. And look what happens when a plasma rotates. It forms its own North Pole, South Pole. Well, you can't see the South Pole on this because of the post. But it forms its own tropical equators and pulses from the equators going up and to the north and to the south. And the orientation doesn't matter on turning it or not. Look at that. Anyway, Mr. Fix-It Rick, huge thing that he found here, and I had to name it. I mean, he didn't name it, what the process that's happening here. I mean, there is no name for it. Something that's electrically oscillating, and plasma is also rotating physically very fast at several thousand RPM, and it breaks apart into its own magnetic field. I would think it would maybe even might have a gravity effect with more power. I don't know. Did we just discover anti-gravity? What would happen if Mr. Fix-It Rick put a scale next to that and a gram of a gram weight, and that the gram weight either weighed more or less next to that spinning artificial magnetic field that's being created by the spinning, rotating, hyper-oscillating plasma? And what if a hyper-oscillating plasma generates its own magnetic field and gravitational field? We already know it's generating its own magnetic field. It's coming out from the electricity, but it's breaking it apart into a north and a south pole from rotating it in the gas. Isn't that amazing? I can't believe we found that. Or I found it. I was just, nobody else found that. I was going through it. I saw Mr. Fix-It Rick's video. I go, what's this? I had wondered in my mind, what would happen if I rotated one of my plasma balls really fast? Would it generate anti-gravity is what I thought. And then I saw his video. I go, holy crap, I can't believe it. It's generating its own magnetic field breaking in north-south pole. And if it does that, then maybe somebody should do the weight experiment and see if it generates its own gravitational field. I propose to you that that's happening in the core of the Earth. And as that is coming up, you saw it pulsing up to the North Pole. As it's coming up, it's causing deep earthquakes to hit the underside of the plate, the wave that's coming up. And that's got to be very low frequency, vibrating out from the core, just like that. You can see it, though, in his experiment, that little tiny plasma ball. But I think it's happening on a vast area. Anyway, I wouldn't have looked into any of it if I would have listened to all the deniers, haters, and people said nothing was happening. No, the core of the Earth is a solid ball of metal. Well, they had to change that. That's been thrown out the window now. Since I've come around, past 12 years, the core of the Earth has went from being a solid ball of metal to a super ionic something or other. And that's where they are now. They're going to eventually find out. It's just like what I was showing you there, but it's a billion trillion times more powerful. It's instead of plugged into your wall or to a battery, it's plugged into the sun. And the charged particles are coming from the sun, hitting the atmosphere and creating that electricity that's powering the torch, the rotating plasma torch down inside of the center of the Earth. Or, well, there's some debate on that. Don't get me going on that. I'm not here to ruffle any feathers. Just something's down there that's being fed power, and it's coming back up, and we're getting deep earthquakes down below. I hope you enjoyed this long 1 hour and 5 minute long update. That's long. I'm going to stop recording now, and we're going to upload this masterpiece over to YouTube. I'm glad we ended with that. But really, the real ending here is for me to tell you to be prepared again. You need to be prepared. You need to have a stock of food and water. I'm not kidding. Do it. You need to do it. I don't care what the cost is. If you have to if you have to hit the pawn shop, whatever you got to do. Stock up. Food and water. Also, you need to change your clothes, a set of shoes, and you need an emergency kit that's got, first aid and sanitation, and an extra set of keys and an extra ID and all that good stuff into an emergency kit. But the food and water thing, that's going to be what you survive on for weeks, if not months, if there's anything that really goes down. And the laundry list of things that could happen now is like I just keep adding more and more to the list. But I'm telling you to be prepared for earthquakes. Everything else, there's 1,000 other channels that are covering everything else that's going on. I'm here to do the earthquake thing, and so are you, so you need to be prepared for that. That means watching the quakes going around the planet and telling people you know. Hey, look, let me sum this whole update up. There's a spread of big earthquakes going around the planet right now. I've already issued warnings for several areas and several forecasts that are out on my channel. I told you where to watch throughout this update. You can go back and rewind and listen. We're watching for multiple new 7s to take place, plus a new 8. That should drive home the point. Be prepared. Not trying to scare anybody. My channel stands for don't be scared, be prepared. And being prepared means facing what's coming. I mean, if we were to ignore the big storms that just developed over the past 2 days, because it's scary to think about, that's not wise. And isn't it more scary to not know about the storm? And just like you're sitting there and the sky gets dark and you hear a rumble of thunder and you look out and you're like, oh, it looks like it's going to get bad. And then it starts getting really, really, really bad. That's more scary. I would like to know. I'd like to know and be watching the weather already and see the front coming and know when to expect it and watch the arrival and see if it's as big as they were saying and all that other stuff. The same could be said for earthquakes. Now that we understand that earthquakes are flowing across the planet and that there's a flow going from one point to the other, there's no reason to ignore it. It's like a flooding river. If you ignore a flooding river and you get caught in the flood, shame on you for ignoring the flood. If you could know about it ahead of time. If somebody hides it from you, that's different, right? Like if somebody hides the flood from you. But denying that floods happen after rainstorms occur, I don't know. There are still people that are denying that there's a flow of energy going around the planet. I don't know why. You can see it. It's like a flood. Again, you can see the flood. If somebody was denying that there was a flood happening after a big rainstorm, wouldn't you look at them a little weird? That's kind of what I've been dealing with the professionals in this denying of flow of seismic energy. It's that level of weirdness. And that they previously said there was never a flow. Like, I asked for proof. I said, did you ever prove that? I said this to a professional who was denying. He said, there's no flow. And I said, do you have proof of that? And he said, no, it's up to you to prove that there is. And I said, well, look, there's a flow of earthquakes going across the craton every week for the last several years I've been watching. And he said, first, I was just cherry picking the quakes. Then he said it was chance and coincidence. That was 8 years ago. And that was the top medal winner, geophysics medal winner in the Pacific Northwest who said it. So it's not like it was some troll. Well, I mean, maybe, actually. 3:07 a.m. Had to end on a high note there. Speaking of that, did you guys see my interview earlier? I didn't know what was going to be on before my interview. I had no clue. Some kind of thing going on. I don't know. Anyway, I did an interview earlier. If you guys didn't catch it, go catch it. Where? Oh, I can't tell you. Have a good afternoon, morning, evening, or night. 3:07 a.m. It's time for me to sign off. It's kind of all three for me. It's morning, afternoon, and night.